thank you so much for joining us. We really appreciate you having you here with us. Sure. And so for my first question, I'd love to know, I know you gave your speech last night, I'd love to know sort of what topics and overarching topics you spoke to the students about.
So I gave a talk for the Phi Beta Kappa chapter here, and I talked about evolution and why it still matters that we understand it and that people teach it, and how it impacts everything from cancer biology to natural history to many aspects of our daily lives that many people don't see because they either don't understand evolution or don't want to, or fear it for some reason because of, of the history of the drama of understanding evolution in this country. But yeah, so I want to give a general talk about that while also talking about my own research on a pretty neat project on some cave fishes from Thailand.
Awesome. So what has been your favorite part about that project?
That project was really fun. We spent about 4 hours in a cave in northern Thailand, not far from where that soccer team was trapped for a little while. Not a little while, a long while. And the cave fishes in that cave, they crawl up waterfalls in the dark and have a really neat anatomy related to basically having a hip. So their vertebral column, their spine, connects to their pelvic girdle, their pelvic bone, which is a hip, and fishes don't have hips. So that these fishes have hips is pretty cool. It allows them to do things like climb waterfalls and things like that. And that converges with, in evolutionary biology, with some of the first fishes that came onto land. So I showed the parallel anatomy, the convergent anatomy that developed independently to allow both of these fishes to essentially walk.
Wow, that's really interesting.
So
I'm
I think it's
picturing
cool, yeah.
it in my head right now.
Yeah,
climbing the walls.
it's fun.
And so what sparked your interest in studying fish in evolutionary biology?
That's interesting, yeah. So I grew up in Queens, New York, and I thought fish were gross. So, and because I was just, fishing in ponds and stuff like that, and didn't really like eating them or anything like that. But I went to McGill University in Montreal with a zoology major, and and I loved animals since I was a kid. And it was cool to do a zoology major at this beautiful campus, quite like Elon actually. And then I did an internship at the American Museum of Natural History in Manhattan, and worked with one of the most charismatic scientists, and her name is Melanie Stiazny, and she's a good friend still. She actually just won the Linnaean Medal, which is a huge deal for us natural historians. And she taught me all about describing and new species of fishes. We described a new species from Madagascar. And she got me in the network of all these other ichthyologists. That's what we call people who study fishes. And I never left that network, and I've been part of that world. And I've learned to love fishes because of their really cool anatomy. Plus, there's lots of new species to describe. There's 36,000 species of them.
That's a lot. It's a great backstory.
Yeah, a lot more than birds.
Oh, yeah. So after doing all that and just doing all your research, what made you want to become a professor?
Yeah, so I lived and grew up in New York City, and I was back there doing a postdoc. That's what you do after your PhD, or many do. And I was applying for curator positions because I loved museum research, and a lot of museums are associated with universities. And so when the position opened up at Louisiana State University, LSU, I didn't really know about their ichthyology program, and they have this wonderful museum, well known for ornithology. That's why I was making fun of birds before, and for their genomic resources. So they have these huge facilities of animal DNA. And so I wanted to be there, and when I got the curator position, it's a 25% teaching, 25% curation, and 50% research. So it's a research professorship. So it's a little different than being a professor at Elon, where we have labs with graduate students and PhD students, and there's 35,000 undergraduates. So it's a little bit different than Elon, but it's a professorship where you're largely judged on the research that you're doing.
Interesting. Well, it sounds very rewarding. It sounds like you've just
built
and taught everybody. Yeah. What has been the most defining moment in your career, would you say?
I mean, for me, seeing PhD students who've been working in my lab for 5 or 6 years working in the field, we do a lot of field work. You know, we've been to, as a group, 50 or so countries, and seeing them work in the field, come back, do the lab work, do the computer work, all this, you know, coding that they have to do, and publish papers and become scientists on their own. Seeing them do that and get the PhD and then get a job, and also, you know, become adults and have children and all that stuff has just been like the best part, and something we don't talk about much as professors. You know, just seeing your lab grow up and develop and become peers is really rewarding.
Awesome. Well, why do you think, or if you think, aquatic biodiversity important?
It's extremely important, aquatic biodiversity, especially freshwater animals. You know, there's this idea, or, you know, most people neglect that how little fresh water there is in the world. So if all the world's water filled a bathtub, about a spoonful would be the flowing fresh water. So there's very little fresh water out there. And so that's all our drinking water. That's all the life for aquatic insects and mollusks and fishes. And many of those are endangered because, you know, we're not great at sharing. And so that's the freshwater side. Marine side, obviously, you know, we think there's huge amounts of ocean out there, and relatively there is, but, you know, most animals are associated with coral reefs, and there's very few coral reefs out there, and they're endangered. So, yeah, I wish more people knew about how limited the space being used for biodiversity is, and how much we can impact that.
Yeah, I know the Haw River, which is right next to Elon, it has one of the most polluted waters, I'd say, especially in North Carolina in the area. And I was wondering if you had any suggestions on how people can help, maybe even Elon students, how we can help sort of clear that up.
Yeah, I think in some of these other places that I've gone that have a great teaching focus, like Elon, students are going out to the local rivers and lakes and testing the water first to see what the pollution problem is. Is it, you know, eutrophication, where there's a lot of algae growing, or is it, you know, other chemicals that maybe are seeping from mines or things like that? So I think first knowing what the problem is, what the source of the pollution is, and then, you know, it's not just the science. It's having people, you know, write articles like you all are doing, doing journalism that can help translate that research to a broader audience. And, you know, that's part of what I'm doing now as a science communicator and scientist. But, you know, the role of journalism and people who can write really well or speak very well can help process that. So hopefully there's a group of Elon students that can go out there and recognize the problem and talk about it and explain it, and then you all in fields that do more outreach and to a broader public can translate that so that everybody understands why it's important to fix is it the Hunter River?
Haw
River.
Haw River.
So
yeah, that's good to know.
That.
Yeah. And so one of my last questions is, how does climate change impact the species that you specifically study?
Yeah, climate change, people think of, you know, mostly terrestrial environments, but with rising sea levels, you know, that can impact animals that live in coastal regions. So there are some freshwater fishes that they're only found, you know, in a small area of the world, and with sea level rise, that'll become inundated with salt water and they'll go extinct. I described lots of cave fishes. I worked on cave fishes, and, you know, with climate change, people are using more and more water from aquifers, and that's the habitat for these cave fishes. So I've described some species that have gone extinct because they flooded those caves to create aquifers for farming. And so the use of fresh water, rising sea levels, are all climate change impacted, and that can impact the fishes that I'm studying. So it's a problem. It's not something you see year to year, but if you look at the course of the changing environment over decades, it does matter. And so, you know, to protect the creatures that I love and that I hope everybody loves, we all have to do our part. But also go after the big companies and other groups and governments that need to be doing more.
Right. Do you have a favorite species of fish or type of fish? I'm sure you've been asked this a bunch.
I've been asked, and I always try to come up with a different one because every day is different. I think the cavefish I talked about yesterday at Elon, Cryptotora, is really cool. It just looks like a salamander, and it's blind and pink, and you know, you could say it may look gross, but it's so gross that it's kind of cute. And so, and it's just a remarkable animal, the way it can move in and out of the water, and it doesn't have a circadian rhythm, and we know that from studying its DNA, its entire genome. And so, you know, how does it turn off? Like, we know when to go to bed at night, but, you know, when you live in complete darkness. And so there's lots of mysteries there, and I'd like to know more. And so right now, today, that's my favorite. Awesome.
Well, that's great to hear. Is there anything else you'd like to add to this interview?
It's just wonderful being at Elon, and just want to thank the Phi Beta Kappa group that invited me, giving a little speech for their induction today. And I'm excited. It's a very different place than Louisiana State University, and a big public research museum, research-oriented university. But I love that the one-on-one interactions that students here can have with faculty. I think that's great, and something I envy quite a bit.
Well, thank you so much for joining us. I really appreciate your time.
Thank you.
Thank
Thanks
you.
for having me.